This video will cover the senior capstone project for the Aircrete generator. This project was sponsored by Josh Ruby, who is a mechanical engineering graduate from BYU, Idaho. Josh runs his own construction business building custom houses in eastern Idaho. Josh would ultimately like to partner with several humanitarian organizations to build low-cost housing in impoverished areas around the world. To help his business and to eventually achieve these humanitarian goals, Josh tasked our team with building an Aircrete generator. Aircrete, or lightweight cellular concrete, is a low-cost building and insulation material that is much lighter and cheaper than traditional concrete. Aircrete uses foam for an aggregate instead of sand or gravel, so the main ingredient in Aircrete is actually just air. Josh wanted his generator to be made for less than $500, be made from readily available parts, be easy to build, and easily disassembled for transportation. Our first step was building a prototype foam generator, which you see here. This foam generator passed soapy water and compressed air through an agitation chamber filled with steel wool to produce foam. This foam was about the consistency of shaving cream. We later rebuilt the foam generator to improve user control over the foam density and flow rate. The ideal density for foam used in Aircrete is about 3 ounces per quart. The next major component was the mixing chamber. Our design centered around an auger attached to a 6-speed mixer that would be used to pull cement slurry from a hopper into the chamber and mix it with a steady flow of foam to produce Aircrete. However, after numerous tests and modifications to our design, we were unable to produce a consistent mix. And so we concluded that the auger method is ineffective for moving and mixing Aircrete. The main issues were 1, foam backing up into the hopper, which threw off the density and flow rates of the final product, and 2, the auger being unable to move a sufficient amount of slurry through the system. For future development of this project, we believe a piston pump with 2 large check valves will be a more effective design. Ideally, the check valves would prevent foam from flowing the wrong direction, and the piston pump would be better suited for moving the slurry. Many attempts have been made in recent years to create an Aircrete generator, but no one has been successful. Our client was ultimately pleased with our first attempt at this project and will likely continue development on it in the future. With the foam generator we created, he will also be able to produce Aircrete via batch mixing, which will be valuable for his business.